Hello, how are you all? So today we will be dealing with some other section for our three-phase circuit itself. Today also we are doing our previous year university question. Okay. So our question is a three-phase 4-wire 400 volt RYB system. So we are having a three-phase 4-wire system. Okay. So you can draw a three-phase 4-wire system first. So because there will be marks for the drawing. Okay. So you can draw a three-phase 4-wire system. Even without drawing, you can draw it, but still. So instead of resistance inductance, I am showing it like this. Okay. So like this. So this is R, and after 120 degree it comes Y, and after 120 degree it comes B. Okay. And they are saying what is ZR? ZR is 10 angle 0 degree. ZY is 15 angle 30 degree, and ZB is 10 angle minus 30 degree. So now you can understand that the resistances or the impedances are different, which means the system is an unbalanced system. So our system is having unbalanced load. The load is unbalanced. As a result, the currents will be different. I'll write it. Okay, currents will not be same. Okay, so as a result, what happens, there will be a current flow through the neutral wire. Okay, so what will be the current flow through the neutral wire? That will be minus of the sum of IA plus IB plus IC. So that is the neutral current. Okay, and how can you find out the value for this line current? That you can find out by using V is equal to we have to find out line current, isn't it? I is equal to V by Z. Like that we can find out. Okay, I is equal to V by Z. And at that time, you should also remember that VR will be equal to 400 angle 0 degree. VY will be equal to 400 angle 120 degree, and VB will be equal to 400 angle 240 degree. Okay, or you can write it as minus 120 degree. Both are same. Now you have to find out the line current and the neutral current. Okay, so I have explained the question because this was a particular type question which we were doing it for the first time. That's why I have explained it to you. So you have to pause your video. And solve it by yourself. After that, play the video. Okay. The question will be seeing something tricky to you, but it is very easy that you have to remember. So VA value, that is 400 angle 0 degree. VB value, that is 400. Okay, sorry, it is R by B. So R VY value is equal to 400 angle 120 degree, and VB RYB, isn't it? That will be equal to 400 angle 240 degree. And what are the values they have given? They have given ZR, ZY, and ZB. Let us go back and you have to write it. Okay, so what is ZR? ZR is 10 angle 0, 15 angle 30, 10 angle 0 degree, 15 angle 30 degree, and I think it is 10 angle minus 30 degree. Let us check it. Yes, 10 angle minus 30 degree. So in order to find out our line current, that is IL, IR line current for IR R phase, then we can say VR, that is 400 angle 0 degree divided by ZR, 10 angle 0 degree. So what will be the value? 400 by 10 is 40. So the angle will be 40 angle 0 degree. That will be IR. What is IY? IY will be equal to 400 angle 120 degree divided by 15 angle 30 degree, isn't it? So what will be it? 400 divided by 15. What will be the value for 400 divided by 15? You have to find it out. That is 26.66. So the value will be 26.66. And what will be the angle? 120 minus 30, isn't it? Naturally, it will be 90 degrees. And what will be the line value for IB? IB will be 400 angle 240 degree divided by 10 angle minus 30 degree. So that will be again 40 angle 10 and 240 minus 30 is 240 plus 30, that will be equal to 270 degrees. So we have our line values for R phase, Y phase and B phase. Okay. Now we have to find out the value of neutral current. Okay. So let me use some other color for finding out neutral current. So IN is equal to minus of this, because it will be opposite direction, minus of IA plus IB plus IC. Okay, that is the equation. So we can write it as minus of, that is 40 angle 0 degree. So we have to use the addition method. Addition for that, for algebraic, for that it is better if we convert it into rectangular coordinate system. Now it is a polar coordinate system, so it is better if we convert it into rectangular coordinate system. Okay, so please convert it into rectangular coordinate system. That is 40 angle 0, you know, that is 40 itself, isn't it? 40 plus j 0 plus 26.66 angle 90. That will be 26.66 j, because angle 90 degree, only imaginary part will be there. Plus, then we are having 40 angle 270, isn't it? So I can write 40 angle 270. That will be equal to minus 40j. Okay. That will be equal to minus 40j. So now you have to find it out. That is minus of 40. This minus 40 plus 26.66 will give you minus 13.34. 40 minus 13.34 j, or we can say minus 40 plus 13.34 j. Or can we write it out? Minus 40 plus 5 into 13.34. 13.34 convert to polar. That will be 42.16. That will be 42.16 angle 161.55 amperes. Okay. So these are currents. So you have to write the unit as amperes. Okay. So that is for this question. I hope you understood what is being discussed in our last question, because it is very easy. Even though we find it like it will be very difficult, because different z values are given, unbalanced the system is given. There is nothing like that. You can just directly find it out. So let me summarize. If you were given ZR, ZY and ZB, in order to find out IR, you can take V angle 0 degree by ZR, and for IY it is V angle 120 degree by ZY, and IB, that will be V angle 240 degree divided by ZB. And in order to find out the neutral current, you have to just find out the vectors. Okay, so why this minus means if all these currents are entering, then this current will be leaving. That is why I have put this minus. Okay, I hope you understood that. And then we are moving on to the next question. That is, 3 impedances are connected in delta. Okay, now we are having delta connection, and all the 3 impedances are same values. 3 phase is having same values. That is very good, because it shows that the load is ballast load. Okay, so and the value is 10 plus J15. All are having 10 plus J15 connected across a 3-phase 400 volt supply. Okay, so which means everything is connected to a 3-phase 400 volt. So I am writing it just as RYB, just I am putting it. Okay, so now we have to find out the line current, cos phi power factor and the active power. What will be the active power? Active power is equal to root 3 VL IL cos phi. That is active power. So in order to find this, we have to find out cos phi and IL because VL is given. Okay. So what is given? The Z is given as 10 plus J15. That is same for everywhere. Okay. And the supply voltage they have given VL is equal to 400 volt. Okay. So please pause the video and go for solution. Okay. After completing it, come back to the video. Sorry, so shall we start doing it? That is, we are having impedances. Okay, we are having impedances. That impedances in the delta connection, you remember, please remember that VL is equal to V phase and IL is equal to root 3 I phase. You have to remember this relations for delta connection. Okay, VL is equal to V phase and IL is equal to root 3 I phase. Okay, now what is given in the question? That is, we were given Z. Okay, that is Z phase. So this value is Z phase. So what will be Z phase? We can find it out. Z phase is equal to root of R square. What is R square? That is 10 square plus XL square, that is 15 square. So what will be the root of 10 square plus 15 square? That you have to find out. Okay, so please find out 10 square plus 15 square and you have to take the root answer. You will get it as 18.027. Okay, I got it as 18.027. That is the impedance value. 18.027 is a impedance value. Okay, now what you have to find out? You have to find out the power factor, isn't it? They are asking us to find out the line current, power factor and the active power. So in order to find out the line current, we should know the phase current. We don't have any idea. Okay, yes, we can find out line current or phase current. How can you find out line current or phase current? First we can find out phase current because I already told you VL is equal to root 3 VL is equal to V phase. I repeat, this is delta connection. So VL is equal to V phase. I am using some other color just to make sure you notice this. Okay, so VL is equal to V phase. So I can say this is V phase and we have, this is V phase, this is our Z phase. It is ohm. Okay, so we have V phase and Z phase. So I will get I phase is equal to V phase divided by Z phase. What is V phase? That is 400 divided by what is Z phase? 18.02, isn't it? So 400 divided by last answer will give you what is 18.027. There is a point in between. That will give you 22.188 ampere. So this is your I phase. Okay, but you are asked to find out your line current. So what is line current? IL is equal to root 3 I phase. So IL is equal to root 3 I phase. So that will be equal to root 3 into this value. Sorry, that is equal to 38.43. So what is this value? 22.188 is equal to 38.43 ampere. So this so that you have found out the value for IL. Okay, so now you have found out the value for IL. Now you have to find out power factor. The same question. Okay, the next you have to find out the power factor. What is power factor? Power factor is equal to cos phi. That will be equal to, you know, the power triangle, isn't it? This is the Z, this is R and this is X. Okay, So you know what is cos phi? That is adjacent side by hypotenuse, isn't it? This is angle phi. Adjacent side is r by z. Okay. So cos phi we can write it as r by z. So what is the value of r? R is equal to 10 divided by what will be the value of z that we have found out, isn't it? Z was 18.027. 18.027. So tell me what is the power factor? 10 divided by 18.027 is equal to 0.554. 0.554. Okay, so that will be the power factor cos phi, and that too will be, you have to say leading or lagging. Yes, it will be lagging because we are having plus 15j. Okay, just look into the impedance. If it is plus 15, then you can see it is a inductor. If it was a capacitor, no, then it will be minus j something. Okay, so you know, when inductor comes, it will be lagging only. Okay, current lags behind the voltage, so it will be lagging only. So we have found out the power factor. Now you have to find out the active power. Active power will be equal to, power absorbed will be equal to active power, that will be equal to root 3 into VL into IL into cos phi. So that will be equal to root 3 into VL is our 400 itself into IL. What was the value for IL? I'm sorry, 38.43. 38.43 into cos phi value is 0.554. Okay, so there is a point here and you have to do it. That is into 38.43 into cos phi into 38.43 into 400 into root 3. That value will be equal to 14,000. That will be equal to 14,769.55, and the unit is watt. Okay, so this usually we notate it in kilowatt, so we can write it as 14.769 kilowatt. Okay, so this is the answer for active power. Okay, so I hope you understood it. Question is very simple. We are given Z. So this is Z phase, that is across here. There is no phase value and line value for voltage. So we can say 400 divided by this will give you I phase. Now then see in the previous slide. So it will give you I phase. Then you have to find out line current is equal to root 3 I phase. Then cos phi is equal to r by z and p is equal to root 3 VLIL cos phi. Okay, so whenever you are getting a question, you have to draw a diagram, then you have to write these two equations. So it will help you to score marks, even though by somehow means if you have any mathematical error. Okay, so next question is, a balanced three-phase load consists of 3 coils of reactance 4 ohm. So they have given reactance 4 ohm and resistance 3 ohm connected in delta. Okay, so they have given you the value for reactance and resistance. In the last they have given it as impedance itself, r plus jx, like that form they have given. Now they have given x and r different, isn't it? So no need of worrying it, we can solve it. How can we solve it? We can just do the mathematical calculations. Like here a reactance is 4 ohm and resistance is 3 ohm, isn't it? So we can say Z is equal to R plus J XL. Okay, so what is R? Resistance 3 plus J into reactance is 4, J4. This is your impedance, and it is connected in delta. Okay, so in order to save the time, I am just drawing delta and you have to assume that there is a delta load connection. Okay, practice so that you can score better by drawing all the diagrams. You want time if you are not practicing it. Okay, so while doing, just do it. Okay, please do it. So you are having Z, 3 Z values, and I think I will take it as R, Y, B. Okay, This is RYB or ABC, you can take it. So it is having consists of 3 coils having a reactance of 4 ohm and a resistance of 3 ohm connected in delta. It is connected across 250 volt. Okay, so now the line voltage is 250 volt and the frequency they have given it as 50 hertz. Calculate the line current, real and reactive power. Now you have to find out the line current, active power and reactive power. So I am pausing the video. Please pause the video and try to do it by yourself. I hope you have done it because it is of the same type like what we have done in our last example. Okay, so let me use a different color. So I'm trying to solve this. So they are asking us to find out the line current as if we have done. So in a delta connection, we know IL is equal to root 3 I phase and we know VL is equal to V phase. Okay, so these are the two equations. So we know VL is equal to V phase, that will be equal to 250 volt. And what will be IL? IL will be equal to V phase by Z phase, isn't it? So how can you tell what is Z phase? Z phase will be equal to root of 3 square plus 4 square, isn't it? That is 16 plus 9 is 25. Root 25 is 5 ohm. Okay, so we can say 250 by 5 will be equal to 50. Okay, so the line current is 50. Okay, very easy calculation, isn't it? So it will be 50. Now so you have got IL is, sorry, you have got I phase, not IL. Okay, it is I phase. I phase is equal to V phase by Z phase and IL is equal to root 3 into I phase. Okay, so that will be equal to 50 into root of 3. That will be equal to 86.6. So IL will be 86.6 ampere. There is a point here. Okay, so IL will be equal to 86.6 ampere. And now they are asking for real and reactive power. Okay, real and reactive power. So what is the equation for real power? P is equal to root 3 VL IL cos phi. Okay, and in order to find it out, we know VL and we know IL. Now we have to find out cos phi. How can you find out cos phi? Cos phi is equal to R by Z. See, like I have drawn in the last. This is Z, this is R and this is X. And this angle is phi. Okay, so cos phi is adjacent by hypotenuse, R by Z. That will be equal to what is the value of R? 3 divided by Z. I think it was 5, isn't it? Z, yes, it was 5. Okay, so cos phi is equal to 3 by 5. So we are finding out 3 divided by 5 is equal to 0.6. Cos 5 is equal to 0.6. Okay, so what will be the real power? Real power is equal to root 3 into what is VL? VL is 250 into what is IL? IL value was, IL is 86.6. 86.6 into 0.6. Okay, so that is equal to 0.6 into 86.6 into 250 into root 3. That will be equal to 22,499.3. Okay, that is what we can write it as 22.5 kilowatt. We can write it as 22.5 kilowatt. So we have found out our active power. Now our question is, we have to find out the reactive power. So how can you find out the reactive power? The reactive power Q is equal to root 3 VL IL sin 5, isn't it? Reactive power is equal to Okay, we can do it. Q is equal to root 3 VL IL sin phi. Okay, so we can find it out. Cos inverse of 0.6 will give you the angle phi. Then you can take sin phi. Then you can multiply it with root 3 VL IL. Okay, or what you can do is you have found out this active power, isn't it? So active power is equal to root 3 VL IL cos phi. And if I am taking this active power divided by cos phi, that will be equal to this cos phi. So cos phi will cancel and you will get the value as root 3 VL IL. That is the apparent power. Then after calculating apparent power, you can find out reactive power is equal to root of apparent power. This is S. Okay, S square minus P square. That is also another method for solving this reactive power. Okay, for easy method, then cos inverse. So what will be phi? Phi will be is equal to cos inverse of 0.6. What will be the value of cos inverse of 0.6? That will be 53.13. Okay, 53.13 degree. And you have to find out sign of the answer. Sign of the answer is 0.8, isn't it? Else you can also use another method. So I will say 0.8. So just multiply this 0.8 here. Okay, you have to multiply the 0.8. I'll write in the next. Okay, so you can find out Q is equal to root 3 VL IL sin phi. So that is equal to root 3 into what was VL? I think VL was 250. 250 into 86.6. 250 into 86.6 into this 0.8. That will give you, that is 0.8 into 86.6 into 250 into root 3. That will be equal to, that your value will be 2399.93 reactive power, isn't it? So it will be VAR. Okay, or you can write it as 2.3 or 2.4 kVAR. This is the unit. Okay, so you can do either like this, or you can do that as, sin square phi theta plus cos square theta is equal to 1, isn't it? So cos value, what is cos value? So we can say sin phi will be equal to root of 1 minus cos square theta, isn't it? So that is equal to root of 1 minus 0.6. What was the value of cos phi? 0.6. Okay, 0.6 square. Okay, so 1 minus 0.6 square, and the root of the answer will give you 0.8. Okay, so then also you will get 0.8. so this is another method. Okay, so I have given you first method is just find out cos phi is equal to 0.6, then find out phi is equal to cos inverse of 0.6, that is 53.13, then substitute phi here. So sin phi is 0.8, and all these values that is one method. Or you can find out the sin phi by using this equation. This is the second method. Okay, then you can substitute the value here. And in the third method we can find out S. So what is S? S will be equal to root 3 VL IL, isn't it? So that is equal to root 3 into 250 into 86.6, isn't it? Root 3 into 250 into 86.6 is equal to 37,498.8. Okay, that is S. That is apparent power. So it is VA. Or you can write it as 37.5 kVA. Now in order to find out Q, you can take the square root of S square minus P square. That will be equal to square root of answer square minus, what was our value for P? P was 22,499.3 square. So the value will be same. Okay, I got it as 29,000. Okay, so the value I got it as some 29,999. Let me check the value once more. Okay, you will get the same answer, 299. So this is 2.9. Okay, 299.93. Okay, VAR, or you can write it as 2.9 kVAR. So you have found out the active power as well as the reactive power as well as the line current. Okay, so this was the question asked for KTU for May 2015. Okay, and next we have given another question, that is this question is also one of a peculiar type. So please pause the video and try to solve it. Okay, please pause the video and try to solve it.